sketch the rational function y is x squared plus x minus 12 over x cubed minus x squared minus 2x. So we can factorize the top, and that is x plus 4, x minus 3. And on the bottom, we can take out an x, and then we have x squared minus x minus 2. And so we have x plus 4, x minus 3 over x, x minus 2, x plus 1. So there are various things that we can tell from this. So if we look at the denominator, it will be 0 when x is 0, when x is 2, or when x is negative 1. So if we start to build up a picture of our graph, we can mark those asymptotes on. So one of the asymptotes when x is 0 is the y-axis itself. Then we have when x is negative 1, and we have when x is equal to 2. If we look at the numerator, we can tell that y is 0 when x is negative 4 and when x equals 3. So that gives us those x-intercepts. We don't have a y-intercept because when x equals 0, the denominator would be 0. And that's why we have the vertical asymptote on the y-axis. The x-intercepts and the asymptotes give us key points on the graph, which we can use for an analysis of where the graph is going to be. So let's think about the parts that make up the graph, the factors. We've got x plus 4, x plus 1, x minus 2, and x minus 3. Now, what we can do is think about what happens in different regions. So, we have to the left of negative 4. We then have between negative 4 and negative 1, which is an asymptote. We have between negative 1 and 0. That's between those two asymptotes. We have between 0 and 2. We have between 2 and 3, and then we have what happens beyond 3. So to the left of negative 4, all of these are negatives. 5 negatives means our function will be negative. When we go to the next region, this one becomes positive, and then we only have 4 negatives, so overall it's going to be positive. In the next region, the first 2 are positive, then 3 negatives, meaning our function is negative. Then we've got a positive, and a positive, and 2 negatives, meaning it's positive. Then we're going to have 4 positives and a negative, so overall negative. And then finally, all of them will be positive, meaning it's a positive. And that tells us the regions that the graph is in. And note it alternates negative, positive, negative, positive, negative, positive. So the leftmost part is negative, which means the graph will be below the axis. So once again, because the top is a squared and the bottom is a cube, when we go off to infinity, either positive or negative, it's going to head towards 0. If we look at the first two sections of the graph, there's only one thing that can really happen here. It has to be positive in this region, so it's going to go up the asymptote in this direction. The graph is going to be 0 here, but then we know that it needs to head towards 0. So the only thing that can possibly happen is that we have a minimum point here, and then the graph comes back towards the axis. Something similar is going to happen at the other end of the graph. If we look at these two regions, the graph must be negative here, so coming in from the asymptote, has to be 0 at 3, but then it has to tend to 0. So it must have a maximum point and then curve over. So we know that the graph has to be negative in this region just here. It's always negative, so it must come in, take some sort of maximum here, and then go back out. And then in this region here, the graph is always positive, so it must do something of a similar nature, except having a minimum value. So this is what the graph should look like. So here is the graph plotted on Desmos, and we can see this region and this region that we described in our graph. And it's difficult to tell exactly what happens here on this scale, but if we zoom in, we can see that it does come down from the asymptote, go through the axis, and then it does come back over and go up towards the axis. So there'll be a minimum point here. And similarly, on this side, we can see that there must be a maximum point somewhere in this region.